So good morning everyone. Good morning. आज हम हाफ सब्ट्रैक्टर, फुल सब्ट्रैक्टर, 4 बिट बाइनरी एडर इसके बारे में लर्न करेंगे. गुड मॉर्निंग. कॉम्बिनेशनल लॉजिक सर्किट में अभी आज का टॉपिक काफ़ी इम्पोर्टेंट है, स्पेशली 4 बिट बाइनरी जो आपका पैरेलल एडर है, कई बार एग्जाम में पूछा जाता है. तो हाफ सब्ट्रैक्टर, फुल सब्ट्रैक्टर के बाद एक हम पैरेलल एडर डिसाइड करेंगे. 4 बिट बाइनरी So, good morning. So before starting class, let me introduce myself and the benefit of Unacademy Plus and Iconic Batch. Myself, Arun Kumar Dubey. I qualified UGC NET and GATE exam with first attempt. I am currently pursuing PhD in Computer Science Engineering. My area of research is deep learning. I have 8+ year teaching experience. I teach GATE students as well as university students. The subject mostly I take digital, ADA, DS, DOC, CT and C. This one is very important, Iconic Batch and Plus Batch. Plus batch mean if you want structured, disciplined learning in the within very less time, if you want to achieve best, then join Plus or Iconic Batch. Plus has benefit of live classes, crash course, weekly test, doubt solving, rank improvement class is there, English and Hindi in both language it is available. And for Iconic Batch, apart from Plus benefits, personal coach, study planner, study booster session is there, personalized test analysis is there, preparatory study material is there. And you may see how much Iconic Batch is beneficial over YouTube free classes and Plus Batch. So in our team, Satish sir already completed discrete, Pankaj sir computer network, Deva sir TOC and going to start CD soon. Operating system is there, CEO is already completed. Apart from these GATE courses, machine learning is also available. So we are providing you best course, best quality with quality that you will not get at any place. The plus subscription after using my code AKDLIVE, you have to pay only 27,225 rupees. This is not payment, this is not fees, it is investment for your career. If you want better life, if you want success, if you want satisfaction, then you should join Unacademy Plus Iconic Batch and use my code AKDLIVE to get maximum discount. For 18 months, you have to pay only 34,650 rupees, and for 2 years, 39,600 rupees, and use my code AKDLIVE. And for Iconic Batch 40, it is changed now. It is 45,000. It's not 40,000 now. It's not 40,000 and it's not 54,000. It is 45,220 rupees and it is 66,000 something. Okay, so join Iconic Batch and follow me on Unacademy, unacademy.com @AKDLIVE. Follow me here. And if you want notes in PDF, all the materials of all session, then you should subscribe this Telegram URL. We share our notes, we share our materials at this place. So go and subscribe. These are our YouTube channel, Characteristics Gate ESE in there for electrical EC. For MEPI XE, you may join Unacademy MEPI XE. For civil engineering, Unacademy Gate C is there. Unacademy Gate Telugu is there, especially in Telugu language. Electrical junction is there for electrical students. Unacademy Gate question is there. Unacademy Computer Science is there with Gate courses is running, and crash course we are conducting in the evening. Unacademy SSC J is there, Engineering Pathshala is there, GS Terminal RRB SSC. So you may join and you may recommend to your friends also. Everything is free. Everything is free here. At YouTube, everything is free. You may recommend to your friends for better understanding, better quality knowledge. So thank you everyone. Now I am going to start combinational logic circuit, half subtractor, full subtractor, and design of 4-bit parallel adder. Design of 4-bit parallel adder. What is combinational logic circuit? The output depends upon the present input only. The output depends upon the present input. Okay. So now full subtractor and half subtractor we are going to learn first. So half subtractor, when we talk about 2-bit subtraction, one is minuend and second is subtrahend. The difference value possibility is if one is minuend, 0 minus 0. One possibility is there. So 0 minus 0 is 0. Do you need borrow at this place? No, you don't need borrow at this place if minuend is 0 and subtrahend is 0. If minuend is 0 and subtrahend is 1. If minuend is 0 and subtrahend is 1, at this point of time you need borrow. You need borrow and borrow 1. So at this stage the difference value would be 1 and borrow is 1. Borrow is also 1. The same thing mentioned in this table, if 0 minus 0 then difference value is 0 and borrow is 0. If minuend is 0, A is 0 and B is 1, subtrahend is 1, 0 minus 1, difference value is 1 and borrow is 1. You have taken a difference value as 1 and borrow is 1 also. And 1 minus 0, if the scenario is 1 minus 0, obviously if minuend is 1 and subtrahend is 0, you don't require any borrow. You don't require any borrow, and 1 minus 0 is 1 and borrow is 0. And 1 minus 1, difference is 0 and borrow is 0. So we have to implement this truth table, these combinations in a circuit. So before implementing this truth table in a circuit, so first let's implement it into a K-map. So what is the equivalent K-map? What is the equivalent K-map for this truth table? So let's find it. Let's make K-map for difference truth table and borrow. For difference, For difference, 4 combinations are there. Zero minus zero, difference value is 0. 0. 1 is 0 minus 1, difference value is 1. It means the combination is 0 1, the value is 1, difference value is 1 0, difference value is 1, and 1 1, difference value is 0. Yes. So difference D equal to, can we form a group? No. So what will be the result? AB complement, AB complement plus BA complement, and it is equivalent to A XOR B. It's mean if 2-bit difference if you want to find, and one is A and another is B, one is A and another is B, so difference value would be A XOR B. The difference value would be A XOR B. It's clear? Okay. And for borrow, for borrow, the K map is 0 0 1 1. Okay. For borrow, only one place is there at the combination 0 1, the borrow value is 1. So 0 1, borrow value is 1. It means it is here, and at remaining place it will be 0. At remaining place it will be 0. So the borrow equal to, what is the min term for this one? A equal to 0, B equal to 1. It means it is A complement B. So this is the borrow, this is the borrow, and this one is the difference value. This one is difference value for half subtractor. Okay. So for half subtractor, D equal to A minus B is equal to A XOR B, and borrow is equal to A complement B. So it's clear. So let's convert it into a circuit. So I have taken A and B, I have taken A and B as input, and for difference I use XOR. This is XOR. This is XOR. So what is the role of XOR? If same values are there, then it will be, output would be 0. If different values are there, then output would be 5. Okay. So A complement and B for borrow, the expression is, Boolean expression is A complement B. So we have implemented it using AND gate. So this is the borrow value. This is the borrow value. But there is one limitation. One limitation is there for half subtractor. What is the limitation? If I want to subtract multi-digits, in multi-digit subtractor, we have to subtract 2 bit. We have to subtract 2 bit along with the borrow of the previous digit. In the multi-digit subtractor, we have to subtract 2 digit along with the previous, along with previous borrow, okay. So that cannot be possible through half subtractor. In this situation we need full subtractor. So limitation, what is limitation? For 3 bit subtraction, we need full subtractor, and that is not possible through half subtractor. This is not possible through half subtractor. Why it is not possible? Because apart from minuend and apart from 2 bit minuend and subtrahend, you need an extra bit to subtract, that is previous borrowed digit, To overcome this limitation we need full subtractor. So now let's learn full subtractor. In the full subtractor, a circuit has 3 input and 2 output. In the full subtractor, a circuit has 3 input and 2 output. Why it is 3 input and 2 output? One is A minuend, second is B, and third is borrow in. Previous digit borrow, that is borrow in, and output is the difference value T and borrow out. Okay. So similar to previous example, it was borrow out, it was BO, borrow out. Whenever you need a borrow, you mention here. Okay. The same way we need borrow out. For example, let's take one example. 1 0 1 0 1 1. I want to subtract this. So 1 minus 1. There is not any borrow in here. So 1 minus 1 is 0. And borrow out is 0 for this situation because you have not taken any borrow. And for next digit 0 minus 1, is it possible? No. How is it possible then? Then it is possible when you take a borrow from adjacent bit. So I took 1 as a borrow. For this. From 0 it has become 1 0. So 1 0 minus 1 is a 1. And borrow out is 1. Difference value is 1, borrow out is 1. For the next 0 minus 0, क्या करते हैं? 0 minus 0 is 0. But if previous borrow is 1, so it is 1 minus 0 1 and 1 minus 1 0. Okay, 1 minus 0, what you have done here in this scenario, first you have subtracted 1 minus 0. So what is the value? 1. Now the previous borrow is 1. Previous borrow digit value is 1. So 1 minus 1, and that will become borrow in next stage. So 1 minus 1 0. So its answer is 0 1 0. Okay. So in last situation, just see in the last situation, the A value is 1, B value is 0 and the B in is 1. B in is 1. Why B in is 1? Because previous output, B out, in the previous output difference was 1 and BO is 1. Okay. So along with 2 bits, we need a extra bit borrow of the previous digit required. That is previous digit. What is B in? Borrow of previous subtraction. It's clear now? It's clear at this place? Okay. So in the same way, we have created a truth table. So you may verify this truth table. 0 minus 0. Borrow in, if it is borrow in 0, so 0 minus 0 is 0 and borrow is 0. If 0 minus 0 and borrow in is 1 in the previous digit, the borrow of previous digit subtraction is 1, like in this example. In what will be in this situation? 0 minus 1. 0 minus 1 require 1 borrow. So 1 borrow is 1 here. Borrow is 1 here and 0 minus 1 and 0 minus 0 equal to 0 and 0 minus 1 equal to डिफरेंस वैल्यू क्या होगी 1 और बोरो क्या होगा 1. ऐसे 0 minus 1 is 1 and for this subtraction you need a borrow, so I have added borrow here and 1 minus 0 is 1, the difference value is here. Okay, so in the same way it is so easy. 0 minus 1 you need 1 borrow, so I put borrow here and 0 minus 1 is 1 and 1 minus 1 is 0, so difference value is 0. In the last you may see 1 minus 1 is 0 and for 0 minus 1 subtraction you need a borrow, so I put borrow here and 0 minus 1 equal to 1, so it's 1. It's clear? This truth table is clear. So now we can create a K-map for this truth table. K-map for difference and for borrow. For difference, the total number of inputs are 3. So truth table, as per truth table, how many cells are required? 2 to the power 3, 8 cells are required. 8 cells are required. So let's make 8 cells. A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay. So if this is not a C, it is a B in. It is B in. So A, B, B in. If A is 0, B is 0 and B in 0, so difference is 0. If A is 0, B is 0 and B in is 1, difference is 1. Difference is 1. Okay. If A 0, 1, 1, 0, 0, 1, 1, difference value is 0. And 0, 1, 0, 0, 1, 0, difference is 1. Similarly, this place would be 1, this is 0, this one is 1, this one is 0. Can we create a group in this K-map? Can we create a group in this K-map? No. So what we will do? Individually we can write the difference. So difference D equal to, what is this? It is 0, 0, 1. It's mean A complement, B complement and B in plus this position 0, 1, 0, A complement, B in complement plus A 1, B 0, B in 0. For this position, A, B complement and B in complement plus last position 1, 1, 1, A, B and B in. If you solve this difference equation, you will find D equal to B in XOR A XOR B. Now let's see K-map for borrow. K-map for borrow. So in the same way, we require 8 cell. Same way we require 8 cell. So A, B, B in is for borrow. Combinations are same 0, 1, 0, 0. So for borrow out, this is borrow out, this is BO and this is B in. So 1 is at 4 place, 0, 0, 1, then 1, 0, 0, 1, then it is 1. Next one is 0, 1, 0, 0, 1, 0. This one. For next 0, 1, 1. A equal to 0, B equal to 1, B in equal to 1. Okay. And the last one is all 1. It's clear? यहाँ तक क्लियर है? Borrow. Okay. Can we make grouping and remaining part is 0? Can we make grouping here? Yes. यहाँ 2 की grouping होगी. 2 grouping is possible. One grouping is here. Next grouping is here. And last grouping is this one. So borrow equal to borrow out is equal to, for this grouping, A equal to 0 and B in is 1 common. A equal to 0 mean A complement and B in 1, it's mean B in, plus for next grouping, horizontal grouping, A0 B1, it's mean A complement B, and last group vertical grouping is B1 B in, B. So this is the borrow. Good morning, good morning. So this is the borrow. It is a full subtractor. So why do we need full subtractor? There was limitation in half subtractor. So 3-bit subtraction is not possible through half subtractor. In that scenario, we need a full subtractor. In that scenario, we need a full subtractor. Now, we are able to find the difference and borrow. We are able to find difference and borrow. Now, can we create circuit? Can we create circuit for difference and borrow? Yes, we can. Yes, we can. So let's create. The difference is B in XOR A XOR B. This is the difference, and borrow is borrow out. That is borrow out. What is the borrow out? A complement B in, A complement B in plus A complement B plus B in. Okay, so let's create circuit for this. So XOR for difference, XOR of A, B and B in. A, B, B in. So A complement B in, A complement B in. So let's make it A complement. A complement mean add not here, A complement and B in. Combinedly, this will be added through AND gate. Okay, A complement B in, it is over. Now A complement B, A complement B, this is the A complement, and take B from this place. This is B, this is B, and this one A complement. Let's take from this place. This is A complement B, and B in B and B in now. We have to perform OR for the borrow. Good morning, good morning. Good morning Ujjwal, good morning Girja, good morning Nidhi. And please like and share with your friend this video. So it's clear. So we need full subtractor to remove the limitation of half subtractor. Let's take one example. Let's take one example. One, zero, 0, 0. I want to subtract this. This is minuend and subtrahend is 1, 1, 1. This is the subtrahend. Okay, let's subtract this. In the first subtraction, 0 minus 1, A is minuend, 1 is A equal to 0. So 0 is minuend, 1 is subtrahend. For 0 minus 1, you need a borrow. You need a borrow. So borrow. I am going to write B in here and borrow out here and difference at this place. Okay, this is my method. 0 minus 1, the difference value would be 1 if borrow out is 1. We have taken borrow out as 1. 0 minus 1, 1. Now for this next bit, borrow out is 1, that will become borrow in as a 1. In the first position, borrow in 0. So 0 minus 1, 0 minus 1, you need a borrow. So borrow out is again 1, 0 minus 1, and the value is 1 after borrow out 1, and 1 minus borrow in 0. So it will be 0. Again this borrow out will become borrow in for next place. Now again 0 minus 1, borrow out will be 1, and 0 minus 1 is 1, and 1 minus borrow in is 0. So difference is 0. At the last place, 1 minus 0. 1 minus 0 is 1. Do you need borrow? No. So borrow out for this scenario is, and the previous borrow out will become borrow in for this scenario. So 1 minus 0 is 1. 1 minus 1 is 0. And borrow out is 0. Okay. So the difference is 0, 0, 0, 1. Difference is 0, 0, 0, 1. So clear? I hope it is clear now. Okay. Now the next topic for today's class, is 4-bit design a 4-bit parallel adder using full adder. So before design a 4-bit parallel adder, let's understand full adder. What is the benefit of full adder? You may add 3 bits A, B and plus carry. A, B plus carry. So full adder, if you talk about the full adder, A, B and carry in. So sum and carry out. This is the scenario for full adder. This is scenario for full adder. Okay. If I want to add 1 0 1 plus 0 1 1, this scenario, in this scenario 1 plus 1 sum is 0. This is sum. This is sum and carry out 1 plus 1 0. Carry is 1. Next time this carry out will become carry in. So 0 plus 1 1 and 1 plus carry in 1 plus 1 0 and carry out is 1. Again this carry out will become carry in for next one. So 1 plus 0 1 and 1 plus 1 0. This is carry out 1 and next 1 0 0 0. This is sum. It's clear? So now this is 3-bit addition. This is 3-bit addition. This 3-bit addition I want to implement through a full adder. I want to implement through a full adder. So how we can do? How we can perform this 3-bit? If I add one more bit, then that will become 4-bit. So for 4-bit, so 4-bit this is parallel adder. Four-bit parallel adder. For 4-bit parallel adder, for first bit you may use half adder or full adder. For next bit you have to add full adder. For next bit you have to add full adder because 3-bit addition is there in the next bit. In the first LSB place you may use half adder because 2-bit is there, or you may assume as a carry in as a 0 and use full adder also. Okay. So let's make for LSB this is the LSB place. The carry in carry in is grounded. It means it is 0. For full adder, for first LSB place, carry is 0. The sum is sum 0 S0. S0 will be the addition of A0 and B0. A0 and B0. Okay. And the carry out of this adder carry out, C out, carry out of this full adder will become carry in, will become carry in C in for next full adder. And you will get next sum value S1. A1 and B1. Okay. फिर again the carry out of this full adder will become carry in for next bit addition. And this is A2 and B2. S2. And last one, sorry, yes, last one, this carry out will become carry in for last full adder, that is 4-bit full adder, and A3 B3 B3 and sum S3, and next last is carry, last carry out CO. It's clear how you can design the 4-bit, how can you can design 4-bit parallel adder. ये समझ में आया? Are you able to understand this one? Okay. So what we have done, we have added A0 A0, A1, A2, A3, B0, B1, B2, B3. We have added this one and you got S0, S1, S2, S3. Okay. So let's take one example. One zero 1 0, and I want to add 1 0 1 1. So 0 plus 1 for first full adder. Let's check, will it be possible? Yes, 0 plus 1 1. Is there any carry? Carry out is 0. Carry out is 0. So and that will become carry in for next. Carry out is 0. Next that will become carry in for next bit addition. So 1 plus 1 0 and 0 plus 0 0. So it means some value is 0, but carry out is 1. Carry out is 1 and that will become carry in for next bit. So now 0 plus 0 0 and 0 plus 1 carry in is 1. 0 plus 1 1, carry in and carry out is 0 now. So the next carry out C will become input for next full adder, and 1 plus 1 0, 0 plus 0 0. Next carry out is 1 and it is 1 here. 1 plus 1 0 0 plus 0 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 0 So clear? The 4-bit parallel adder. So the question may be asked, design a 4-bit parallel adder using full adder. Okay, now next question, that is the gate question. It is related to gate question that you may, in semester exam also the same question may be asked. The question is, how many full adder required for 4-bit addition? How many full adder required for 4-bit addition? 4-bit binary addition, how many full adder required? Yes, your answer is 4. 4 full adder. But someone may give you option that is it possible that 1 half adder and 3 full adder, 1 half adder and 3 full adder can also perform same task? How many full adder required to add, it is the gate question, add 16-bit binary number? So answer was 16 full adder, or that is also that may also be, yes Vishwajit, 4, but that can also be implemented through 15 full adder plus 1 half adder, plus 1 half adder. So it was the option there, 15 full adder plus 1 half adder can design 16-bit parallel adder. Okay, because LSB is required only half adder. Even LSB addition is possible through half adder also. LSB, please, this is the LSB and that can be possible through half adder. This is the LSB, least significant bit. You may implement through half adder also. You may use half adder for this. It is on you. You may use half adder for this. Okay, so it was gate question. Gate 2000 something, 2004 gate question was there. Okay, now this is 4-bit parallel adder. Similarly, similar to this 4-bit parallel adder, can we design n-bit parallel adder? Yes, we can design n-bit parallel adder. This is the last topic. It is so easy. How? What is the block diagram for n-bit parallel adder? Just use it full adder or half adder for LSB. The C in will be 0 for LSB. You may ground it, and the sum for LSB as 0, and input for LSB position A0, B0, and its C out will be C in for next full adder. Similar to this full adder, you may also create a full subtractor also. So using full subtractor, you can design parallel subtractor also. A1, B1, this is S1. C out, C in, that is C in for next full adder. S2, A2, B2, and so on up to N. N bit, because it is N bit parallel adder, so it will go from 0 to N minus 1. Okay. So now homework. Yeah. Good morning, Viswajit. Good morning. So homework. What is the homework for you for today's class? Design N bit parallel subtractor. Design N bit parallel subtractor. So N bit parallel subtractor can be designed using full adder also, because for subtraction you may use ones complement or twos complement method, and if you are using ones or twos complement method, it means after all you are going to perform addition. You are going to perform addition. Is clear? Is clear, Viswajit, Girja, and Ujjwal, Nidhi? So today we have learned about half subtractor, full subtractor, and design a 4-bit parallel adder. So first we have completed half subtractor, and using XOR and we have created the circuit. The difference is XOR, and the half adder. Half adder also sum was XOR. That you should be aware. XOR आपके half adder में भी था और यहाँ भी है. For sum also, for difference also. And after that we learn full subtractor, and then parallel adder. So we have completed today's topic. So thank you everyone for being present here, and I request you, please like, share and subscribe these videos and channels, and share with your friends also. For any query you may send me a message on my Unacademy profile, unacademy.com/AKDLIVE. This is my profile. This is my Unacademy profile. Please follow. So this is my Unacademy profile. You may follow this and send me any message. Okay. And these are our YouTube channel. Go and share with your friends. Everything is free here. Everything is free here. Don't hesitate to share with your friends also. So thank you Viswajit, thank you Girja, thank you Ujjwal, thank you Nidhi for being present here. Okay. So thank you everyone.